This is lecture 2. This is about data and sampling techniques and statistical studies. Now let's start with data collection. In a statistical study, we have to collect data to carry out the statistical study. And here are the common methods of collecting data. And there's one direct observation. You just directly observe the subjects and get information from them by just observing. Now, sometimes you do experiments on subjects and you get data from them, from the experiments. And the last one and the most popular one is the surveys um, on the subjects. You ask them the most common methods are telephone survey. Survey means like Estebana, and mailed questionnaire, and personal interview. And nowadays, it's popular surveys using internet, like it might be websites like SurveyMonkey and social media surveys. Now, these all methods of collecting data depends on what you want to do. It depends on your study. Sometimes surveys are better, but if you have to do an experiment, for example, if you're trying to do a medical statistical study, it's better you do experiments. And sometimes you just do observations, look at the cars and count them and try to get data by observation, depending on your topic. Now, as we do sampling, the sampling is basically just taking samples from the population. So it's a method or procedure for specifying how a sample will be taken from a population. Now, why do we take samples from the population? Um, because simply it's impossible to study the whole population most of the time. And it will cost less, it will take less time, it will take less energy. Instead of dealing with the millions of people, it's better you deal with just like 100 people or like 1,000 people. Sampling is maybe the most important part of the statistical studies. Now, the goal in sampling is to find a good representative subset of population. So your sample should be a good representative of the population. So let me give you an example of what I mean by that. For example, you assume you want to conduct a research on the popularity of football among people, and assume you take all samples from men's college, and now your sample will be biased. So here, why biased? What I mean biased is you are excluding some part of the population, women, and also your sample excludes women and is taken from among the young people. So what about the old people? What about old men? And what about the women? So it is biased. So because it's only taking a small specific part of the population. So our goal is to choose and to do an unbiased sampling. So we should try to get samples that are unbiased. So it means our survey should give each subject in the population an equal likely chance of being selected. Okay, after we make sure we did all the requirements and all satisfied the conditions to make our sampling unbiased, we can use random sampling techniques, and these are simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So these are the 4 basic random sampling techniques. Now, simple random sampling. Now, look at the picture. The picture tells what's happening here. You just put the subjects, the population. Think of the population. You put the population here. It shows the names, but you put numbers here: 1, 2, 3, 4, 5, 6, and away. And then you blindly choose numbers from here, and you choose numbers, let's say 1, 11, 50, let's say 61, 71. And these selection will make a sample here. So basically, the first, okay, this is called random, simple random sampling. And here are the steps here. You give numbers. to each subject. Then choose um, some random numbers from these numbers, and this will make the sample. So it's like this, you put the numbers and you choose, you want to choose 10, you just choose 10 numbers. I mean, in systematic random sampling, we have a population here. Okay, this is assume we have a population, and the population is numbered like 1, 2, 3, 4, and it keeps going. And now you choose a starting point among the numbers, starting point, starting number, and then you choose every Kate number chosen. Here, then we have another Kate number, and then K more, K more. So it goes like this. Here in this example here, it goes like 3 plus 3 is 6, plus 3 it makes 9, and then it makes plus 3 it makes 12, and it makes here 15. So we are every third number after 3, every third number is chosen. So the set here, the sample is like 3, 6, 9, 12, 15. And what I want to also um, emphasize that you can start from a different starting point. So if you choose starting point like 2, this will happen. For example, if you choose from 2, it will go like 5, and then it will go 8, and then it will go 9. So sorry, it's 11, and then from 11 it will go to let's say 14. So your sample set might be, if you choose from a different starting point, you might get the sample set as like 2, 5, 8, 11, and 14. This might happen. Now we will see the details of what to do. I mean, how to do this. We will see the mathematics behind this random technique. I mean, sampling technique. First, we have the population size. This is big N, let's say, and we want to choose the sample size. This is sample size N. We want to choose little n subjects from the population. First, we divide n by n, and we round the results to the nearest whole number. This will be a whole number, okay? Round it to the nearest integer. And let's say this is k, and this will be your sampling interval. So it will tell you the kth element. We always skip k elements. So this is k here we found. And now randomly select the first subject C, and C is always less than K, by the way. So yeah, it's better you always choose like C less than K, and then you start with C, and it goes like C plus K, then K more, it will go like C plus 2K, and you will choose these numbers. These are the numbers of these. Representing your subjects. So this will make your sample set. Let's see an example. Okay, let's assume that our population is 17. Now, and we want to choose 6 samples. Now, here what we do here is big N is 17, a little n is 6, and then you want to choose a k. K 17 over 6, which is, okay, this is like 2.6 something, I guess, or 2 point something else, maybe 2.8. But when you round it to the whole number, this will be 3. round to the nearest. Okay, to the nearest whole number, so it will be 3. So you can say this is k is 3. Then if it is k is 3, then you choose a starting point, and this starting point will be choose a starting point um, c less than or equal to 3. You can choose, let's say, okay, let's choose 3. Let's choose let's see, be 2. Then what happens? Let's see, 2. Your samples are then samples are okay. It's better. We don't. Okay, it's better. You take less than this 3. Okay, this is our starting point is 2. You add 3, the multiples of 3. So you add like 6, and you add like 9, you add 12, and so how many we have now? 1, 2, 3, 4, 5. Okay, the next one will be 15, which is 17. So you see here, the samples are 2, 5, 8, 11, 14, and 17. If it happens that you get more, you have to pick only the first 6 of them. Okay, but yeah, this is the procedure. This is an example of how we apply it. In stratified sampling, the population is divided into groups according to some characteristic. For example, I will show you this one here. We can call each group strata. Strata means tabaka. Okay, stratum means tabaka. So, for example, when you look at the population, you can make this tabaka according to the economic income, low income, middle income, middle class, and then the high income. So you can classify the people this way: high income, or these are the strata here. These are all strata. And then you can do the, if it is stratified, you have the strata of the population, and you choose your samples from. You're taking the samples from each. And this might be economic level. This might be, the strata can be different characteristic, like the men, women, population here. And here, this is, economic status. That's the characteristic in making the groups or the strata. And here the men and women, this is the gender here. And you can make you can divide the population into this type of strata. Let's say if here in Saudi Arabia, we can make the Yemenis people. This is nationality, the Saudi, maybe other here. So I don't know. I mean, I'm not sure about the population here, how the diversity. So these are the nationality here. I don't know. So these are stratas here. So basically, you're picking, your samples from each strata. This will make your sample set. Cluster sampling, we divide the population into clusters. So when we say a cluster, we can define it like it's like the subjects, the collection of subjects in most of the time, usually in the same place, in the same place. We can make the definition in the same place or region. For example, you can make the population this way. Population. You can divide the population into like the people in about people in Riyadh, okay, and then this is cluster 1, and then the people in uh, Dammam, this is cluster 2. So you can put lots of clusters here, and then make the sampling here. So how do you make the sampling? So you say, for example, you make the sampling like cluster 1 plus cluster, say, 7. And if you pick 3 clusters, okay, these are the clusters. All of them, all the people in the cluster are samples here. All the people here. And we are not choosing the samples. They're just making the sample here the equal. So we are putting all the people inside these clusters as the samples, not picking the people from each cluster. We're just putting all the people in the clusters as samples. And you can also give the example of schools here, the villages. Mostly it's about the place, the cluster, not another characteristic, not like the young people, old people, or like the high income class. This is different, uh, different than, different than. It's not cluster is not strata. Okay, not they're not the same. Look at here. For example, when you conduct a survey of school children in a large city, we could randomly select 5 schools and then include all the children from each selected school. So you have cluster 1. Your cluster 1 is, let's say, clusters. So in this example, you have your clusters are schools. School 1, and it goes like school N. So then you choose, let's say, 5 schools. You choose school 6, school, say, 20, 20, 30, and 31, and 41. So these are the schools. You are putting all, you're not taking one student from each. No, you are putting all the populations in the schools all together. This makes a sample. Okay. In stratified sampling, you choose samples from each stratum. But here, you directly, if you choose a cluster, cluster means a collection of people in a location, you put them all in the sample. This is the difference between the cluster sampling and stratified sampling. Now, here, look at this picture. It gives a nice comparison between the sampling techniques. Um, let me tell you what is this orange people, the orange, let's say, woman. Okay, the characteristic is, let's say, gender here, and for the stratified sample, and then the gray is men, let's say, and the boxed ones, the chosen guys, okay, the chosen people, like these samples here. Look at here. In a simple random people, so we have men and women together. And in a population, and we pick randomly, like this guy, this guy, or this guy, or this guy, this guy. Then we don't pay attention to whether they're men or women. We just blindly choose them. We might have more men, or more women. It's not important because we are doing simple random sampling. But in a systematic sampling, we give numbers to them. We 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then you choose a starting point. The procedure how to select, and then you select the sampling interval. And if you want to choose here 1, 2, 3, 4, 5, okay, just 2 plus 3, it's 5. Then plus 3, it makes 8, and then 11, then 14. You choose these guys. These are so they might be women or men. It's not very important. But in stratified example, you divide the population into women and men, and then you choose from this stratum, women, 2 of them, and then from men, you choose 3 of them. So it makes the sample like these are my sample: 2 women, 3 men. But in cluster sample, this is, look at here, this is cluster 1, there's cluster 1, there's this cluster 2, there's this cluster 3, there's this cluster 4, there's this cluster 5. As you see, we don't pay attention to whether the clusters have, man and woman, because each cluster will allow woman, men. I mean, it's not very important. The important thing is like when you choose a cluster, you choose it. And then we pick these 2 clusters here. The cluster 2 and cluster 4 are chosen as your sample. So when these 2 clusters are chosen, then you choose your sample set will be now, samples will be here, how many women, 2 women here, 2 women, and 4 men. So you see, when you choose the clusters, you put all the populations of all the numbers, all the populations of the clusters in the sample. But in stratified, you choose from each strata. So some people from the strata, not all of them. You're not taking the people in the strata. So this is a nice picture here to give an idea about all techniques. Now, the country is divided into economic classes, and a sample is chosen from each class to be surveyed. So what type of technique is it? So you are making the population into like high level, high income, the middle class, economic classes. So you make stratum, by the way. So it's a stratified sampling technique. Imposter uses a computer to generate 500 numbers, random numbers, and interviews the voters corresponding to these numbers. So what type? So you choose like 500, but 500, it's like you're drawing numbers from a hat, a bag. So, but you don't do it, you let a computer do it. 500 random numbers from the population. So it's, what is this? This is simple random. Now, an educational researcher selects 36 middle schools and interviews all the teachers at school. So these schools are making clusters. So from each, you chose 36. I mean, there are lots of schools. So you choose these clusters, 36 of them, and you make interview with all teachers in these schools. So this is a cluster sampling. Okay. Now, a group of businesses, according to type: medical, retail, restaurant, hotel, and the other. And select a random of 10 businesses from each type. Which technique is it? So 10 businesses from each. So it doesn't say I'm taking all from one. Okay, if it was cluster, then you take all the people in cluster. Plus, in the cluster, the main characteristic is the location. So for this reason, it cannot be clustering. But here, there are different types. We divide the businesses into types. So it's like stratum we build, and then we take a sample of 10 businesses from each type. So we have stratum here, stratas. We're taking 10 from each. So this will be stratified sampling. Now, every 7th customer entering the shopping mall is asked to select, or every 7th. Here you have the first one, then every 7th, this is the 8th, then 15. So as you see, this will be systematic sampling, and systematic random sampling. Now, we have 2 types, statistical study. One is observational study, and there are lots of, also there are some other, there are more here, but we will not see the more part. We will just concentrate on these two statistical studies. One of them is the observational studies, and the other one is the experimental studies. Now, in the observational studies, as you understand from here, the observation, the researcher observes what is happening or what happened, and he tries to draw conclusions from these observations. And the most important part here is this no interaction with subjects. One, there is the observation. The second, there is no interaction with subjects, no modification on subjects, and it will occur in settings. So you put a camera and where you're watching people and you are reporting them. It's like that, and can be expensive and time consuming, yes. But when it is experimental study, so experiment means tajruba here. So when you're doing experiment, of course you have to do something to the subjects. So you have to manipulate the variables and then try to determine how the manipulation influences the other variables. And there's an interaction with the subject. So for example, you give a drug in an experiment, you give drug to people and you check their blood pressure or a sugar level or some other level, some other thing. So this is, you're doing an experiment. And of course, there will be some modifications on the subject, and this is what you want to see. Um, then here are some examples of them. Now, in the observation studies, for example, in a study, the researcher records the mistakes which has been made by the students in the exam. This is just observational, like all the guys, they wrote their answers and they did their mistakes. We don't have any relation with them now. We just look at their papers. Researcher counts the number of people living in each house in a specific street, just counting. And researchers stood at a busy intersection and see whether the age of the driver is related to passing on red light. So basically, you can do it with putting a camera and observe the people passing on red light. And this is observational study. And I'll look at here the experimental studies. Patients are randomly assigned to two groups, and you divide them into two groups, the patients, and then you give them a drug, and the other group another drug, and then you want to see its effect on the patient's blood pressure. So as you see, you are interacting with the patients and you are giving them medicine. And here, an instructor has 3 new teaching methods. He wants to find the best method by analyzing students' grades for each method. Here, you're applying to your teaching method to students. So you're interacting with students. So this is an experimental study. Now, in statistical studies, might have, that they include independent variables or dependent variables. Especially in inferential statistics, this happens a lot. And we have 2 variables, the dependent variable, this is the outcome resultant variable, and this is independent variable and explanatory variable, sometimes it's called, because this guy, independent variable, it affects the dependent variable somehow, okay? So then we generally explain the change in the dependent variable with the independent variable. Sometimes for this reason, we call it explanatory variable, the independent variable. Now, this variable is studied to see if it has changed significantly due to the manipulation of the independent variable. And the independent, this is manipulated by the researcher. So let's say, for example, you give them drug A. So this is the amount. You make an experiment. You give them a drug to patients. These are your patients, are your subjects. And now you look at the blood pressure. Now, this is a variable. This is another variable. So you look at here. This is independent variable, and this is dependent variable. And this here independent variable is affecting, when we believe it affects the blood pressure we want to see. So if there's a change in the blood pressure, this will explain. This is expected to explain the difference. In some statistical studies, we can encounter a confounding variable. So what is a confounding variable? This is a variable that influences the dependent variable but was not separated from the independent variable. So it happens that it might affect both variables simultaneously. Now, for example, we want to do a research on how the number of schools or the education number of schools I mean, the number of schools, how affect the number of prisons, let's say. So basically, we want to do a resource like education, and we are trying to, characterize the education in terms of schools, and we want to see its effect on crime. But we are looking at this two things here: the number of schools now in years. Now in years, let's say. Now in years goes okay. Now number of schools, you have like 100 schools, and the number of persons like maybe one, and then the in some time later it becomes like 200, and the number of prison in the country or in the city goes 2, and it goes like 250. It's same like 300. It becomes like 350, so it becomes like 3. Maybe it becomes like 400. It becomes like 4. Now, when you look at these two, I mean, you assume this is a independent variable because the changing of independent variable, the number of schools, I mean, we're assuming this is independent and this is dependent because we are assuming the education level, when it gets better, the crime rate goes down. But when we look at here, the number of schools, as they increase, the number of prisons is increasing. Uh, so but this doesn't explain the things here. I mean, this is just the opposite of what we expected. Here, indeed, there is another confounding variable affecting both. It's indeed population, because the population here is let's say 500,000 people, and then 1 million the other year 2 million. It goes like this. Now you see, as the population goes, higher, I mean, it gets bigger, then you expect number of schools gets bigger, the number of prisons increase, of course. So the population here, behind the number of schools, behind the number of prisons, there is a confounding variable, which is the population. So when before doing a conclusion, before making a conclusion, it's better to find to check if there's a confounding variable, and we have to figure this out. Okay, this will be our least concern now in our class, by the way. But it's better you know this what confounding variable is. In experimental sciences or in experimental studies, especially in medicine, there are two groups. One of them is the treatment group, and the other is control group. This experimental studies, we mostly mean the medical tests, like medical exams or experimental studies on the drugs, let's say. And then the treatment group receives the treatment, and the control group doesn't receive the treatment or special instruction. And you give them the drug here, this guy, the real drug, you give them. You want to see the patients here, how they're affected, and you give the fake drug to these guys. And this fake drug is like candy or a vitamin pill or something like this. Let's say candy. And but these guys, they don't know. I mean, this fake drug is called a placebo. Placebo. And I think the reason for this is like some people, even they are given the fake drug or placebo, they get better, and they somehow they recover from the disease. And sometimes it happens that without the effect of the drug, some people get better because of the psychological effect. So they want to eliminate the psychological effect. I think this is why they doing it. I mean, I don't know much about this issue, but this is one of the reasons maybe. Let's look at this example. A researcher wants to investigate the effect of new weight loss pill in reducing weight. The study is conducted by selecting 500 overweight people and reporting their weight before taking the pill. Also, some variables have been measured before the study, which are person's gender, person's age, and economic status. Then 100 of them are given the pill with 5% concentration, 100 with 10% concentration, and 100 with 20% concentration, while the remaining 200 people are given fake pill. After a duration of 6 months, the new weight has been reported, and the conclusion stated that the new weight loss pill really reduced the weight. Moreover, the weight loss pills performs better with females than male, with young people better than the old people. Let's answer the following questions. What is the type of the study? Okay, type of study. It will be experiment, right? We do an experiment. Now, what are the independent and dependent variables? Independent and dependent variables. So, independent, what you give to the subjects, the overweight people, you give a weight loss pill, but with different concentrations. So the independent variable is the concentration of weight loss pill. And the dependent variable is their weight. So their weight depends on how much do they take. According to our study, we are measuring them. Now, how do researchers manipulate the independent variable? They manipulated the independent variable concentration of pill by changing it, by giving different concentrations. So what's the treatment and control groups? The treatment group is the guys taking taking the pill, and the control group are the ones who didn't take the pill. So it will be the treatment group is the 100 people who took pill, and the control group is the 200 people who got fake pill. So here it's 200 people they were given fake pill. Now, state some variable that doesn't affect the study. Okay, what's not related to the weight? So the effect of the pill, I mean the gender, we have some gender here, the gender issue, because the gender is also affecting the efficiency of the pill. This is female more than male, and young people is better. So the age is also involved in the study. It affects the efficiency, but the economic studies not found anything related to it. So economic studies has shown no relation to the study. And then conclusion, what's the conclusion? The new weight loss pill really reduces the weight. Now let's look at this example here. In 2010, a medical research center in South Africa has invented a new medication that can reduce the infection of HIV and wants to test a new drug on patients. The study has been conducted at an HIV clinic. Some patients have been given the drug while others have been given placebo, so which means like fake syrup or infective syrup, without telling the patients whether they got the real drug injection or placebo injection. The infection has been tested at each patient's visit during a period of 1 year. Then the collected data has been analyzed, and a comparison between the two groups of patients has been done. The study concludes that the new medication has significantly reduced the HIV infection, and those patients who used it are getting better than the others. Now let's answer the following. What is the type of study? So it's very obviously it's experimental, because we have a treatment group and control group. We give them a new drug um, to HIV patients. What are the independent and dependent variables? Okay, what is affected? The infection, HIV infection. So we can say amount of HIV infection is affected by the new medication. So we can say independent variable is new medication. And how the researcher manipulated the independent variables. The independent variable is new medication intake. So we give new medication to treatment group, and we don't give medication to the control group. This is how we manipulate it. And what is the treatment and control groups? Okay, the treatment group, these are the patients, the HIV patients who are given new medication, and control group is the patients who are given fake medication. Now, let's state some variables that had no or the least effect in the study. In here, in this passage, the other variables, the reported variables are not explained here. So there we don't see them. But we can think ourselves like it seems like age, I'm sure it's age of the patients are reported, or their gender or economic status. And we can see, we can assume they do not have any effect on the test, on here, on the study. Given on conclusion of the study, the new medication has significantly reduced the HIV infection. Now let's solve the worksheet. Now, a tax auditor selects every 100th income tax return that is received. So tax auditor means like tax inspector. So the people are paying tax to the government, and then they report their taxes. They have their reports. They have reports, tax returns. Then this guys, the tax auditors, are inspecting each report, and they inspect every 1,000 income tax return. So you send them to the tax IRS, who's an institution, and then they're not checking all of them. They're checking the every 10th of income tax return. So what sampling is used here? So as you see here, they picked the first one, then the 1,000, 1,000, 2,000. So this is, as you know, it's systematic sampling. To find out whether car accidents are more likely on rainy days, a researcher records the weather conditions during 50 randomly selected accidents for the past year. So what type of study is used in this example? So basically, in the accident days, we are checking. So accident day, accident one, you check the weather condition on that day. So this is just coming from observation. So it's not experimental. It's just you're looking the weather report on that day. You're making the observation of the weather for the day the accident happened. So this is an observational study. A variable that interferes with other variables in the study is called, okay, we said about this, like this is confounding variable. This variable interfere with the independent and dependent all the variables. So we say it is a confounding variable. So a market researcher selects 500 drivers under 30 years of age and 500 drivers over 30 years of age. So selects some samples from 30 years of age and over 30 years of age. So under 30 and over 30, what type of sampling? So here, the drivers are chosen from these two groups, like under 30 and over 30. So it makes the population into what? Two stratum, according to age, right? So this will be then, so you're taking the samples from these subgroups of the population. So these are making a strata. They're not, these groups are formed by age. So then this is stratified. So if it was cluster is about the locations, you know. A randomized experiment was done by randomly assigning each participant either to walk for an hour 3 times a day or to sit quietly reading a book for half an hour 3 times a week. So there's an experiment, and we are assigning each participant like walk or read, let's say, for some time in a week. And at the end of the year, the change in the participants' blood pressure over the year was measured. And the change was compared for the two groups, like the guys reading and the guys walking. The two treatments in the study were, so we treated the groups, we give special instructions to them. What are they? So one of them is walk for half an hour 3 times a week, and reading quietly, reading a book for half an hour 3 times a week. So these are the treatments we gave them. So these are the instructions we gave them to the treatment group. We gave special instructions, you know, these are the treatments. Now, they might not be real treatments, but they're we can say real treatments. A pollster uses a computer to generate 500 random numbers, then interviews with the voters corresponding to those numbers. And pollster is the guy who is asking the people, okay, about their polls, you know, who will you elect, like, for example, Trump, Joe Biden, or Republicans, Democrats, let's say. And this guy is generating, he uses 500 random numbers, and then he goes to the, you know, these voters, the people, and interviews with these voters. What type of sampling is it? So the important thing here is how he chooses the numbers. You know, these here, the numbers are chosen by computer, and it's totally random. So we say this is a simple random um, sampling. So if the information gives the systematic for it, like every Kate, every like 1,000, or every some, yeah, 10,000 people from the population, we would say is systematic. But here, since it's just as like generate 500 random numbers, so this is simple random sampling. An education researcher randomly selects 36 middle schools and interviews all the teachers at each school. What type of sampling is this? Now, the researcher is selecting 36 middle schools, and in the middle schools, he interviews with all teachers. So these schools are making the clusters, and in this cluster sampling, you remember, we pick the clusters and we sample all the teachers in them. Okay, so this makes this, we can say this is a cluster um, sampling. Now, in an experiment, the researcher measures the variable and manipulates the variable. Which variable? Researcher measures in an experiment the dependent variable and manipulates, like he can change the, you know, do you remember the drug? So he gives the drug and testing the blood pressure. So he manipulates the drug. Drug is independent. He manipulates the independent. So okay, he measures the dependence and manipulates the independent. So this is not the answer. So it has to be this one here. Manipulates the drug and measures the blood pressure. So think of this example. So you can change, you control the drug intake. You don't control the blood pressure. You just control the manipulate the drug. So which is independent variable, we call it. In determining the sample interval represented by K, randomly selecting a number between 1 and k, and then including each kth element in your sample are the steps for which form of the sampling. So if you're talking about the determined sample and picking each kth element, we mean systematic sampling. A researcher wants to know if a soil additive makes fern grow more quickly. Soil means earth, soil, maybe you say turab, I don't know. And fern is a plant. This is a plant. Um, he grows one specimen treated in soil, one specimen, like one sample, one plant treated in soil, treated soil, and one in untreated soil. So he puts like this. This is the soil, let's say. So he puts the soil here. This is treated, and this is the soil is untreated soil. In a cup, let's say. Okay, so this you put the additive here. Additive, you put additive here. This is treated now. This is not edited here. So there is this untreated soil. So then, yeah, you grow one plant here, and the other plant is like this. Now, which type of study is it? This is, of course, like it's definitely an experimental one, because you are putting some additives, so you are affecting the variables here, the independent variable. You are manipulating the variable. Okay, a director of a hospital wants to know the opinions of patients about the service quality. He decides to use the systematic sampling. Okay, he wants to use systematic sampling, selects 40 patients from the whole 280 entering the hospital that day. So find the sampling interval. So the sampling interval, if you remember, it's the size of the population divided by the sample size, and we round it to the nearest integer. So population size is 280, and the sample size we want to choose out of 40 out of 280, so it will be 280 divided by the sample size, which is 40. It will make 7, and no need to round it because this is already an integer. So no need to round it to an integer because it's already integer. So the sampling interval will be 7. Now, let's look at the other question. A researcher conducted a study to see the effect of Neve tablet that helps smokers to stop smoking. Thousands of smokers are being selected. Half of them were given different doses of tablet, while the other half were given a placebo. Placebo means fake pill, okay, fake medicine. Their ages, weight, duration of smoking, the number of cigarettes smoked every day have been recorded for 6 months. The result of each group was compared. The result concludes that the Neve tablet does not reduce smoking. 1. Answer the following question. A. What type of study was this? This is observational or experimental. So do we have groups, and are we manipulating the variables? Yes, like we are interacting with the subject. So then we have an experimental study. So we give them some tablet, right? We interact with them. What are the experimental units and control units? The experimental units, like experimental units and control units. We mean experiment treatment group. Okay, this is a treatment group and control group. Treatment group are this is 500 smokers, Smokers that are given uh, different doses of tablet. Now, when it comes to here, the control group, these are also the half of them. Now, those who take placebo, smokers, okay, this is who, and this is who are given placebo, the fake pill. These are the answers.